All right, question 17 asks you to do something with proof by contradiction. And in classic Cambridge style, they've asked you to do this when we haven't taught you anything about formal mathematical proofs. Well, we've kind of done some proofs, but those have just been working through the stuff and showing that the left-hand side equals the right-hand side, so the whole thing must be fine. Sometimes you have proofs by contradiction, and you start off by assuming something, and then you're going to show that if you follow it through logically, you get like a really weird thing happening, and then you can be like, well, if it did equal it, it kind of came out really bad, um, but it doesn't, so we're good. So we're going to start off by saying, well, we want to show that it's irrational, and if you remember, irrational just means can't be written as a fraction. So we're going to use proof by contradiction. We're going to show that we're going to assume that it can be written as a fraction, and then we're going to let everything go pear-shaped. So suppose, by way of contradiction, that. Now, I've done a lot of proofs by contradiction. I've never had to write that sentence, but Cambridge. So we're going to suppose that log base 2 of 3 equals a over b, where a over b is simplified. So when we simplify things, you can't simplify them anymore. There's nothing in common that you can divide by, so no common factors. Okay, so we're now going to play with this until we end up with something that's obviously wrong. And we don't know what we're going to end up with. The thing I'm thinking of to start with is rewriting this as 2 to the a over b equals 3, which means I've got 2 to the a. That's not helping me, is it? No, I'm going to get that b over to the other side. So I'm going to multiply both sides by b. And I'm going to end up with b times log base 2 of 3 equals a. Which means log base 2 of 3, I can now move that b up. Which means 2 to the a equals 3 to the b. Okay, 2 to the a is even. Obviously, because it's 2 times 2 times 2 times 2 times 2, whatever. And this is a times. If I have 3 to the b, then that's 3 times 3 times 3 times b times, which is odd. So 3 to the b cannot equal 2 to the a because, like, 3 to the b, yeah, it's 3 to the n thing. It's always odd because an odd times an odd is an odd. Which is a good one for you to remember. So if I had an odd, then that's like every odd number is 2 times an even number plus 1. And I'm timesing it by another odd number, so I'm going to say 2 times n plus 1. Like, I've got two odd numbers, they're multiplied, then that gives us 4 times m times n plus 2m plus 2n plus 1 times 1 is 1. Like, it's always two lots of like 2mn plus n plus m. Like there's always a plus 1, like it's always odd. Anyway, so 3 to the b cannot equal 2 to the a because 3 to the b is odd and 2 to the a is even. Therefore, we have a contradiction. So what were we starting off with? Log base 2 of 3 is irrational. So we essentially started off by saying log base 2 of 3 is rational, so it can be written as a fraction. We then followed that through to like a logical conclusion, and then we discovered that, well, that means that an odd number equals an even number, which can't have, well, obviously an odd and even, they're not equal to each other. So that was our contradiction. So therefore, it can't be irrational. It can't be rational because everything went wrong. And that's a proof by contradiction, and that's my least favorite method of proof. My favorite method of proof is induction, which if you do year 12 extension, you'll enjoy as much as me. They're actually fun. Well, they're my version of fun.